In this segment of experiments, I continue to deal with the simple pendulum in its various forms. And as I told earlier, in its looks, in its construction, it is trivial, but it can do certain very fascinating experiments. We can do some very fascinating experiments with it. One of the forms is this pendulum. Very simple pendulum, but it has got a plastic tube through which the thread is passed, which gives me, say, a choice of increasing the length or increasing and decreasing the length of the pendulum while it is oscillating or stationary. The second one, again, a simple pendulum, but instead of a bob, I have a china cup hanging with it. And the other end of the string, I have a very small weight to keep the string taut and also to hold it. The third continues to be the swing, which already has been shown in earlier demonstrations, but it is still capable of performing. It's simply a plastic base with a string attached to it and acts like a swing. The fourth form is slightly interesting, it's slightly different and needs a careful look at it. It has a plastic ball at one end and a plastic tube of L shape going through the ball. At the other end of the ball, through the plastic tube, we put a thread. At one end of the thread is a small bob, green color, hanging. The other end of the thread is a weight, a plastic bottle filled with water. The effect of this is that this ball represents, the yellow ball represents the sun, this represents the earth, and the plastic ball weight, which pulls the cord, acts like, somewhat like gravity. Not exactly, because this is a constant weight and gravity changes with distance. But two qualities are there. It is attractive, and second, it is radial. With these four sets of simple instruments, we'll now be conducting some very fascinating experiments. Thank you. Now we have the same swing with which we had done an experiment where apparently the water defied gravity. Now the same swing, this time, we'll hang it over a beam, a small pencil. And if I release the string, the swing along with the water is expected to go down because of the high weight. And if I release the string, what happens? The swing along with water is bound to crash down to the ground. But see what happens. The string behaves in a magical manner. Here again we have a simple pendulum, but instead of a bob, I have a china cup at one end of the string and a small weight at the other end of the string. I hang the china on a pencil. As I loosen the string, the china cup starts falling because of the heavy weight towards the ground. But if I leave the string, what happens? Just observe. Just observe. Now you saw, the string virtually acts like magic, holding the cup just before it crashes to the ground. When you do this experiment, be careful to use an old cup, because however, in the beginning, you are bound to lose few cups unless you learn to adjust the length of the string and the weight of the cup. In this contraption, I have a ball, plastic ball representing the sun. As explained, I have put a tube and a string going through the tube. At the other end of the tube, I have a small green metal bob representing the earth. I have a weight hanging at the other end, which can be varied by increasing the amount of water in it, and it apparently gives an effect of gravity. You can see as I leave the bob, it gets pulled towards the sun. Though it is not exactly a replica of gravity because this is a constant force while gravity changes with distance. But it is radial, and see what happens. Suppose this is the earth, this is the sun, and the earth is coming from somewhere and going somewhere. Suddenly on the way, it encounters the sun, and the sun starts pulling it towards itself. Look what happens then. The earth is coming from somewhere, going somewhere. I leave the earth. It starts revolving around the sun. The surprising result in these three experiments which you just saw can be understood by closely and repeatedly observing the various motions of the constituents of this experiment, and also keeping in mind the laws of conservation of motion, particularly conservation of energy and angular momentum. Rather, in 17th and 18th century, scientists used such and similar experiments to uncover and frame the various laws of motion. Thank you.